Okay, this is Matgen110. We are looking at the Chapter 9 notes. So let's take a look. Remember when it's factored and it's equal to 0, the only way to get to 0 through multiplication is if this is a 0 or this is a 0. So if we were told to solve this, we'd take 2t plus 1 equals 0 and 3t plus 4 equals 0. And now we go back to week 2, where we were solving two-step equations. Isolate the variables, so subtract 1 from both sides. And then divide by the number in front of the variable to make a coefficient of 1. And there is one solution, negative 1/2. And then the other solution, subtract 4, isolate the variable, and divide by 3. And so t is equal to negative 4/3. So if I substitute back in negative 0.5, there and there, it'll get me 0. If I substitute back in negative 4/3 there and there, it'll get me a 0 in this one. 0 times anything is 0. A negative 1/2 will get me a 0 in this one. 0 times anything is 0. And so those are our two answers. Let's take a look at this one. We can do this one without factoring. We can do it by taking kind of the square root of both sides. Let me show you what that looks like. So we do the square root of this side and the square root of that side, but whenever it's an even root, you have to look at two answers, the plus or minus of those, all right? And so that square root and that square kind of wipe each other out, so we're just left with a minus 3. This is plus or minus the square root of 16. Let's isolate the variable. We'll get that 3 over to the other side. And so a is equal to 3 plus or minus the square root of 16. Now, if that were the square root of 17, we'd be done. We'd just circle it and be done. But the square root of 16 is a perfect square, which means I can go further. I can basically make that a 4, right? The square root of 16 is 4. Now I can add and subtract it with the 3. When it was a square root, I couldn't add and subtract it, but when it's just a regular number and a regular number, we can do this. So 3 plus 4 is one answer, and 3 minus 4 is one answer. So one of our answers is 7, and one of our answers is negative 1. And you could sub both of those back in. 7 minus 3 is 4, squared is 16, negative 1 minus 3 is negative 4, negative 4 times negative 4 is also positive 16. All right, let's look at the next page. Okay, there's a couple more problems. So we're on the note packet. We're looking at page 7. I think this is 8 and 9 were both in the same packet. So that's why we're all the way on page 7 already. All right, so we isolate the variable. And then we do that plus or minus the square root thing. And since it's 25, now this is a shorthand. You can leave it like that if you want to. You could also say x equals 5, x equals negative 5, if you'd rather make it look like two different answers. But that's a shorthand. Plus or minus means there are two answers there. So isolate the variable. Divide out the 2. And do the plus or minus square root. All right. Let's look at the next one, 5a. It says, use this equation. Find out how far the ball goes in 2 seconds. So we just put a 2 in for t. And that's pretty easy. That's just 4 times 4.9 on our calculator. So 19.6 meters. I think B is a little trickier. B is definitely a little trickier. 5B looks like this, where they gave us 40 is equal to 4.9 t squared. So they said, look, if it goes 40 meters, how long is it in the air? That's a little harder of a problem because we'll divide the 4.9 out, and that gives us this kind of ugly decimal. And now we got the t squared, so we're going to do the plus or minus square root. That's just t now. But here, the minus doesn't make sense because it's time. So that's out. And so it's just the square root of 8.16, which is 2.857. So about 3 seconds. About 3 seconds. Oh, they said tenths, so 2.9 seconds. All right. Okay. So let's look at number 6. That is a Pythagoras Theorem problem. And Pythagoras Theorem is a squared plus b squared is equal to c squared. That's actually where all trigonometry came from, right? Right triangle trig, the sines, cosines, tangents, all that stuff. All born from good old Pythagoras Theorem. So here's x, here's 3x, here's 10. So we have a squared plus b squared equals c squared. This is a, this is b, this is c. So we're looking at x squared plus 3x squared, 10 squared. That is x squared plus 9x squared equals 100. That is combined like terms, right? That's 1x squared plus 9x squared is 10x squared equals 100. Divide out the 10. X squared is equal to 10. And then plus or minus the square root. Again, it's a length, so negative doesn't make any sense at all. So we do that, and that's about, the square root of 10 is 3.162277666. Forever, it's irrational, non-terminating, non-repeating decimal, but we'll just call it 3.2. And so now we take that 3.2 and put it back in there and there. So one of our lengths is 3.2, but the other length is 3.2 times 3, which is 9.6. And those are going to be approximations. If you square that and add it to this squared, it won't be exactly 10. It'll be in the neighborhood, but it won't be exactly 10 because we rounded off 3.1622222. All right? All right, and that's it for 9.1. Completing the square is going to be its own video. That's 9.2. That's coming up next.